let's look at this question. Suppose it is reported that 20% will vote for candidate A. Immediately we can tell that population proportion is 20% or 0.20. You think this percentage is different in your neighborhood, so you decide to randomly sample 164 people. So N, the sample size, is 164. You ask them if they will vote for candidate A. Is the sample size large enough? So this is sampling distribution of sample proportion. The way I can tell is I do have a population proportion and a sample size, so to me it looks like a binomial distribution. However, the sample size is large, it's huge, so I know I can treat it as sampling distribution of sample proportions. In order to test if the distribution is normal, I need to test this rule that says n times p times 1 minus p must be greater than or equal to 10. So let's see if this is satisfied. So I'm gonna do the math. You can do it on Excel. Since I'm already on Excel, I'm going to try to do the math here under. So this is equal to N is 164. Let me just say this one. 164 times P is 0.20 times, and then open parentheses, 1 minus 0.20. And then close the parentheses. As you can see, the answer here is 26.24, which is definitely greater than 10. So the answer here should be yes. So when I'm answering that question on here, the answer should be yes. So I'm going to just type yes here. Going back to the next part. The next part is asking me to compute the mean of distribution of sample proportions, which is, we know it's equal to the population proportion. So in our case, it's 0.20. So the answer here should be 0.20. And I will go to my question and I will plug it in. So this is 0.20 is the sample mean. Next, the next question says, what is the standard deviation of distribution of sample proportion? That is the square root, according to the rule, it is, or the formula, it is the square root of p times 1 minus p divided by n. So if I want to figure out this, I would definitely start finding the answer to the expression inside, and then I'll take the square root. So I'll do it with you here. So first I'm going to compute what's inside of the square root, that is p. I could have basically typed p here. So p equals 0.20, and then I have n equals 164. It would have been easier for me. All right, so equals, it says p here, so I'm just going to click on p times 1 minus p. So open parentheses, 1 minus, and then click on p again, and then close everything, and then divide by n. So that is what goes under the square root. And then I'll take the square root, which is going to give me the final answer. So I'm just going to put the answer here. I'm going to say this is equal to what's under the square root? Sorry, so SQRT is for the square root, and then what's under the square root that we computed previously. So that would be the, this is going to be the standard deviation of distribution of sample proportions. I can round this to 0.0312 or 123. 5 decimals. I think that's reasonable. Okay. And I'm going to plug that into my question online, paste it there, copy, and I'll paste it over here. The next question says here, suppose we find from our sample that 135 will vote for candidate A. So now that we have everything, we know that X is equal to X, let me write it here. So X is equal to 135. This is basically the value for X, because that is what satisfies what we're looking for, which is who are the people voting for candidate A, or how many people are voting for candidate A. In order to find p hat, we know that p hat is equal to X divided by n. In other words, it is 135 divided by 164. So I'm going to compute the p hat right here. equals 135 divided by 164, and this is going to be the answer. I will go ahead and paste that into my answer, and then eventually I need to answer the last part, which is what is the probability that at least 135 people will vote for candidate A. So at least 135 people voting for candidate A means the least could be 135, but it is going to be more than 5. So I need the probability that at least 135 people, so that is going to be p hat is greater than 135, because we are looking at a sample here. We do have a sample. As you can see here, we have a sample of 164. Out of the 164, what is the probability that at least 135 of them will vote for candidate A? So we're looking for the probability that the sample proportion is greater than 135 over 164. So that is what this means. We need to deal with proportions in this case. If I want to graph it, so here is the normal distribution curve. And I know that the population proportion is 0.20. And I want to look for whether more than 135 people out of the 165 voted for candidate A, and that is this proportion right here. So 0.82, if I round it to 2 decimals, is approximately here. Notice that if you deal only with the number 135, there is nowhere you can fit it into this normal distribution, because all of the numbers at the bottom are proportions, that is basically less than 1. So there is nowhere for you to fit it. I'm looking for this area right here, so I want to find the area to the right of 0.82. So in order to figure out the area to the right of 0.82, you will use 1 minus norm distribution. So this is going to be 1 minus norm dot distribution to the right of what number? That is 0.82, or basically the p hat. I can click on this p hat when I'm computing it. Rounding it too much can give you some rounding errors, so I would not recommend that you use the rounded version of p hat. Comma the mean. We know the mean for this distribution is 0.20. And then comma the standard deviation, so the mean goes here, and then the standard deviation goes here. The standard deviation, we computed it, it's this number right here, so I'm just going to write it 0.031235, and then comma true. You can basically type true there. And then I'm going to compute the values here, so this is equal to 1 minus norm dot distribution, and then open parentheses, norm, missing an M, double click that one, norm distribution, let me remove that, of 0.82, that is the p hat, comma the mean, 0.20, it's short, so I'm going to type it, comma the standard deviation, comma true, or you can type 1 basically for the option, and that will compute the value for you. So it is impossible, so the probability is 0, so that tells me it is impossible for 135 out of the 164 to vote for candidate A with that small probability of voting, which is 20%, so 0. The answer there is 0. And as you can see, all of the answers are right. So if you did get 0, that's totally okay, because it does make sense. The probability is very low. And out of 164, that is more than 50% of the voters. So the majority of the people you chose from your neighborhood voting for candidate A, the probability is 0. I hope this video helps. And if you have any questions, let me know.